Hello, this is Ms. Page. In this lesson, we are going to be looking at introducing the reciprocal trig functions of our sine, cosine, and tangent ratios that we learned about in right triangle trigonometry. So we're going to just kind of briefly refresh our memory about how we define sine, cosine, and tangent of an acute angle. And so here we're looking at for angle B. Angle B is up here in this corner, and so we want to label the three sides of our triangle. The hypotenuse we know is always across from the right angle, so that will be our 10 centimeter side. Then we have what we call the opposite and adjacent sides to our angle, which has to be angle B. So opposite side, we start at our angle and go across our triangle. So in this situation, the 6 centimeters becomes the side opposite angle B, and the 8 centimeters then would be the side adjacent to angle B. We also have a made-up word, mnemonic acronym, that we have learned that helps with identifying or remembering the definitions of sine, cosine, and tangent, and that is SOHCAHTOA. So this tells us sine is opposite over hypotenuse. So the sine of our angle B would be the side opposite, which is 6 centimeters, over the side adjacent, or sorry, over the hypotenuse rather, for H, which is 10 centimeters. The centimeters would basically cancel each other out, and then reducing this to simplest form would give us 3/5 in this case. Then we have the cosine of angle B, which is defined as adjacent over hypotenuse. Adjacent is our 8 centimeters over our 10. Simplest form would be 4/5. And then we have the tangent of our angle B, which is defined as the side opposite over the side adjacent, which would be the 6 over the 8, which in simplest form would become 3/4. So we are going to now introduce the reciprocal trig functions of sine, cosine, and tangent, what we call them. So here we're looking at the same idea, just here's our sine of an angle. Here we're using theta to represent our angle, which is shown here. So you can see that the side opposite angle theta would be there, side adjacent here, and of course the hypotenuse is across from our right angle. The reciprocal of sine is cosecant, and here they are spelled out, so you want to make sure that you understand how they're spelled out and also how they're abbreviated in this notation, this mathematical notation. So cosecant is abbreviated CSC, CSC. Then we have here cosine of our theta. Its reciprocal is secant of angle theta. And secant is a little easier abbreviation because it's just the first 3 letters, SEC. And then we have our tangent function here. Its reciprocal is called cotangent. And cotangent is here. And its abbreviation is rather simple too because it's also the first 3 letters. Cosecant is the one that I most often see people do incorrectly because it's not the first 3 letters. It can't be because COS is our abbreviation for cosine. And so cosecant became CSC. So all we do to find cosecant is we take and we do the reciprocal of opposite over hypotenuse. So notice it becomes hypotenuse over opposite. For cosine, its reciprocal of secant becomes hypotenuse over adjacent. And for tangent, its reciprocal of cotangent simply becomes adjacent over opposite. So here we are going to find the 6 trig ratios of angle theta in their simplest form. So here's our angle theta. Here we're given all 3 sides. This is a 3, 4, 5 right triangle, which is one of our what we call Pythagorean triples. And so we want to start by labeling the 3 sides. Hypotenuse again, always across from our right angle. Side opposite, always across from the angle we're working with, which is theta. So that would be the 4 in this case. And then that leaves the 3 to be the side adjacent. Again, anytime you feel it's necessary, you can fall back on SOHCAHTOA to get sine, cosine, and tangent. So I'm just going to start with those, the most familiar ones. So my sine of angle theta, always make sure that you have that theta there. You always have to have an angle with your trig abbreviation, or it doesn't, mathematically it's incomplete or doesn't make sense. So sine is opposite over hypotenuse, which would be 4/5, which doesn't need to be reduced or simplified in any other way. Cosine of angle theta, adjacent over hypotenuse, would be 3/5. And then the tangent of angle theta, which is opposite over adjacent, would be 4/3. The reciprocals, to complete to get all 6, now we have to know which reciprocal is which. So the reciprocal of sine is cosecant. So we have cosecant of theta. So that would be then the reciprocal of 4/5, which is 5/4. Reciprocal of cosine is our secant ratio. So the secant of angle theta would be the reciprocal of 3/5, which would be 5/3. The reciprocal of tangent is cotangent, and cotangent of theta would be the reciprocal of 4/3, which would be 3/4. So those are the basics. Now, one of the things that can take, of course, a little bit of time is to be confident about what the reciprocals of sine and cosine are. Generally, people don't have trouble with tangent because its reciprocal, cotangent, includes the word tangent. So that's usually not a big deal. But sine and cosecant, cosine and secant, sometimes you're just not sure. And so one of the little tricks that I was taught to help keep it straight is that sine starts with S, so its reciprocal starts with C. And cosine starts with C, so its reciprocal starts with S. So for reciprocal functions there, it's always an S with a C, an S with a C. For sine and cosine, their reciprocals start with the other letter. They can't start with the same letter. All right, so let's take a look at this one. So here again, we are given all 3 sides of our right triangle, but this time one of the sides is irrational, our square root of 13. So we likely will have some more simplifying to do because we don't want to have that irrational number in any denominator of a simplified answer. And here's our theta this time. So opposite and adjacent are a little bit different, of course. Hypotenuse, of course, is still across from your right angle. But now with your theta being in this upper corner, going across our triangle, that makes the 3 the side opposite, and the 2 then is left to be the side adjacent. So starting with my sine of theta, sine is opposite over hypotenuse, so I get 3 over the square root of 13. This one needs to be rationalized to be in simplest form. And that means that the denominator needs to become a rational number. And you might recall how we do this. We multiply by a ratio of 1, which is equivalent to the square root of 13 over the square root of 13. And then we end up with here 3 root 13. And the square root of 13 times the square root of 13 is the square root of 13 squared, or the square root of 169. And those reduce or cancel each other, leaving us with the 13. So that would be the simplified form of our sine theta. Now let's talk about its reciprocal. So this time I'm going to do sine, cosine, or tangent, and then its reciprocal. So our reciprocal is cosecant. So we have cosecant of theta. Now, cosecant of theta is the reciprocal of sine. We could technically use the reciprocal of the original ratio or our simplified ratio. The smart thing to do is to use the reciprocal of whichever one requires the least amount of work after that. So in this case, using the reciprocal of our first ratio is the smart way to go, because when we flip that over, we have 3 in our denominator, which is rational. So we don't have to do any simplifying. We're done with it. Then looking at cosine of angle theta, Cosine of angle theta is by definition adjacent over hypotenuse. So this gives us 2 over the square root of 13. So it also has to be rationalized. And rationalizing here, we're going to use the same ratio because we still need to simplify that or rationalize that square root of 13. And so this becomes 2 root 13 over 13 for cosine. Its reciprocal is our secant. Remember, C with S and S with C. So we've got our secant of theta. And again, we can use the reciprocal of my original ratio or my simplified ratio, whichever one is going to require the least work after that. So I would go with my first one, because in doing that, I don't have to do any simplifying. Then I have my tangent. So I have my tangent of angle theta. And my tangent of angle theta is by definition opposite over adjacent. So that is 3 over 2. In this case, that one doesn't require any simplifying because it's already a reduced fraction. And then its reciprocal of cotangent theta would simply be 2 over 3. All right, so in this third example, we have to realize that we are missing one side of our right triangle. And so here we have to correctly use our Pythagorean theorem to find that measurement first before we can find sine, cosine, tangent, and their reciprocals. So we have to still remember where the hypotenuse is, because in our Pythagorean theorem, that is always our C value. So this being our hypotenuse has to be the C in our Pythagorean theorem, a squared plus b squared equals c squared. Other than that, it doesn't matter. So if you want to consider the 3 being the a or the 3 being the b, that doesn't really matter, okay? So here I'm just going to say 3 squared plus b squared equals my 4 squared. This gives me a 9. This gives me a 16. This gives me a 7, and so my b is the square root of 7. So that's this side right here. Whoops, 7. Then I would move on just like I did in the previous problem. So now I'm going to label the other two sides, opposite and adjacent, and do my trig ratios. So from my angle theta, which is here in this corner now, going across my triangle, I hit the side that's 3 units, and so that would have to be my side opposite, leaving my square root of 7 to be my side adjacent. All right, so now I'm going to start with sine. So my sine of angle theta is by definition opposite over hypotenuse. So that one doesn't require any simplifying. Then its reciprocal, remember, if sine starts with S, its reciprocal is the new one that starts with C, which will be cosecant, which is abbreviated CSC of theta. And so flipping that over, we get 4/3. Nothing to do there either. Then looking at cosine of theta. Cosine of theta by definition is adjacent over hypotenuse. So that's the square root of 7 over 4. Also, nothing to do there to simplify because our irrational number is in the numerator. Then we go to our reciprocal of cosine, which remember has to start with S, since cosine starts with C, so that makes it secant of angle theta. Flipping over our ratio, we now have 4 over the square root of 7. Now we have to realize, okay, we just ended up with that irrational number in our denominator, so here we have to rationalize, multiplying by our ratio of 1, square root of 7 over square root of 7, which will give us 4 root 7 over 7 for secant. Then we've got our tangent of angle theta, which by definition is opposite over adjacent, which gives us now 3 over the square root of 7. So again, this one needs to be rationalized. So multiplying by that square root of 7 over square root of 7, we now have 3 root 7 over 7 for our tangent. When we go to do our reciprocal of tangent, which is our cotangent. So we have cotangent of angle theta. Again, we could flip the original ratio or the simplified one. Smarter thing would be to flip the original, which puts that square root of 7 in the top. So we do not have to do any other simplifying. All right, so for this last example here, we again have one unknown side of our right triangle. So we'll need to use our Pythagorean theorem to find it first. And so we need to recognize that this time the unknown side is our hypotenuse, which again must be the c in our Pythagorean theorem. A squared plus b squared equals c squared. So now we're going to end up with 2 squared plus 4 squared equals our c squared. This gives us 4 plus 16, which is 20. Then here, we're taking the square root of both sides, and here we have to realize that the square root of 20 can be simplified. That's part of the in simplest form of our instructions, because 20 has a factor that's a perfect square, 4. So we have the square root of 4 times the square root of 5, and that gives us 2 times the square root of 5. So now I'm going to put this into my little triangle to help there for reference and label the other two sides, again relative to where theta has been positioned, which is in this bottom corner now. So going across the triangle, I hit the 2, so that by definition must be the side opposite angle theta, leaving the 4 to be the side adjacent. And then I'll begin with my sine ratio. So my sine of angle theta is opposite over hypotenuse. So here we get 2 over 2 times the square root of 5. Couple of things we need to recognize are necessary here to get this into its simplest form. One you might have already recognized is we have to rationalize. The new part of this one that we need to recognize is necessary is the reducing of the factor of 2, because this is 2 times the square root of 5. So 2 is a factor and then becomes a common factor between numerator and denominator. So this reduces, which now gives us 1 over the square root of 5. And then rationalizing that square root of 5 with our ratio of 1, square root of 5 over square root of 5, gives us a simplified form of our sine of the square root of 5 over 5. Now, quite honestly, I just did those two things in 2 different steps. They can also be done at exactly the same time. Nothing wrong with that. You can reduce and rationalize at the same time when you have both to do. Reciprocal of our sine is, remember, the one that starts with a c, which is our cosecant. So cosecant of theta. I could do any of the reciprocals that I want to. I can do the original one shown here in blue. I can do the reduced one here in orange, or I can do the simplified one in green. Smartest thing would be to flip the one in orange, because that has a denominator of 1, so that is just the square root of 5, and I'm done. Then looking at my cosine of angle theta, cosine by definition is adjacent over hypotenuse, so now I have 4 over 2 times the square root of 5. Simplifying here is basically the same as simplifying with the sine, because the 2 in the 2 root 5 is a factor, so 2 is a common factor between the 4 and the 2. Reducing gives us a 2 and a 1, so the reduced form is 2 over the square root of 5, and then rationalizing that with our ratio of 1 gives us a final simplified cosine ratio of 2 root 5 over 5. The reciprocal of our cosine, remember, must start with s. That makes it the secant. So secant of theta. Again, I can flip the original ratio in blue, the reduced ratio in orange, or the simplified that is in green. I would choose in this case the reduced, because when I flip it over, it's done. Because the denominator is now a rational number, the reducing was already done, so it doesn't need anything else to be simplified. Then we have our tangent of angle theta. which by definition is opposite over adjacent. So that gives us 2 over 4, which does reduce to 1/2, but of course doesn't need to be rationalized because 2 in the denominator is a rational number already. And then our cotangent of angle theta, which is its reciprocal. Flipping either one of them, not a whole lot to consider, but you could probably look at 1 over 2 and go, oh, well, the reciprocal of that is 2, and just write 2 for the purposes of the notes. I'm going to write 2 over 1, which equals 2. And then that gives us all 6 of our trig ratios. So that does finish up the examples here in this particular lesson, and we are good to go. Have a lovely day.